Hi everyone, welcome back to PRAKASAM tutorials. In my previous video, we have discussed about what is random variable and what are the conditions of the random variable. Now here we are going to discuss about types of random variable. So basically there are two random variables. So that are discrete random variable and continuous random variable. And what is discrete random variable and what are the examples of discrete random variable? And what is continuous random variable? What are the examples of the continuous random variable? So these are we discussed in this video. First, we are going to discuss about discrete random variable definition with example. A discrete random variable is a random variable with a finite range or countably infinite. A discrete random variable is a variable that can take on a finite number of distinct values. In other words, a discrete random variable is a variable that can assume that at most a finite or countably infinite number of possible values. So that is the definition of discrete random variable. And the good example of a discrete random variable is an example of a discrete random variable is the number of children in a family. The number of children in a family is the discrete random variable. That is a finite number. So that can be represented using a discrete random variable. So that is a good example of a discrete random variable. And one more example of a discrete random variable. Let us take an experiment of tossing three coins at the same time. So tossing three coins at the same time, the possible outcome of the experiments are capital S is equal to head, 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 tail, head, tail, head, tail, head, 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 tail, 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 head, tail, 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 head, tail, tail, tail. So these are the total outcomes of the experiment of tossing three coins. So now here let us take the random variable x is defined. The number of tiles is the number of tiles. The random variable x is defined as the number of tiles. And these are the total outcome of the experiment. In this total outcome of the experiment, now where the random variable capital X is defined as the number of tiles. In the first outcome of this experiment, there is no tile. There is no tile. There is a finite number. There is a finite number. And the second outcome of the experiment is head, head, tile. Now here the random variable x is defined as the number of tiles. In the second outcome of the experiment is the number of tiles are 1, which is the finite number, countably infinite, that is a finite number. And the next outcome of the experiment is head, tile, head. In this outcome, the number of tiles are 1, the number of tiles is 1. And next outcome is tile, head, head. So now where the random variable x is defined as the number of tiles. So the number of tiles in this outcome is 1. Next outcome of the experiment is head, tile, tile. So in this outcome, the number of tiles of these outcomes are 2. And in this outcome, the number of tiles of the experiment are 2. In this outcome, the number of tiles are 2. In this outcome, the number of tiles are 3. So now here, the random variable x is defined as the number of tiles. The random variable x is equal to 0, 1, 1, 1, 2, 2, 2, 3. So these are the finite numbers. Finite number of distinct values. So this is the one more good example of a discrete random variable. And another example of a discrete random variable is number of telephone calls arriving at an office in a finite interval of time. So these are the examples of a discrete random variable. Next, we are going to discuss about continuous random variable with example. A random variable that can take on an infinite number of possible values is known as continuous random variable. Such a random variable is defined over an interval of values rather than a specific value. And in other words, and one more definition of a continuous random variable, in the range of a random variable x is an interval of real numbers, then x is a continuous random variable. In other words, one more definition, a continuous random variable is one that can assume any value is some interval of real number. This is the definition of the continuous random variable. And the example of a continuous random variables are, first example, an example of a continuous random variable is the weight of a person. And one more example of a continuous random variable is the random variable capital T. The random variables are represented by capital letters. So capital T is the random variable that the first call of the day is received at a local police station is continuous. Since here the value of the random variable capital T lies in the interval, that interval ranges, for example, 7:30 to 7:30 a.m. to 8 a.m. And the continuous random variable is defined for an interval values of rather than a specific value. Okay, capital T is the random variable. The first call of the day is received at a police station is a continuous manner, and that specific value ranges, for example, 7:30 a.m. to 8 a.m. So that is one more example. And another example of a continuous random variable is the voltage across output terminals of a noise generator is a continuous random variable, as the range of the values that the voltage can assume is continuous. And height, weights are the examples of a continuous random variable. And this is the definition of a continuous random variable with example. And one more type of a random variable is mixed random variable. And this is the least important type of the random variable. Mixed random variable is one for which some of its values are discrete manner and some of its values are continuous manner. Some of its values are discrete manner and some of its values are continuous manner, which is called as a mixed random variable, which is the least important type of a random variable. So these are the classifications of the random variable with examples.